Let's quickly talk about momentum. Now we know that momentum is a vector quantity with a formula m times v, unit kg meter per second. Now the thing is that the another thing about momentum is, in a closed system there is something called as principle of conservation of momentum. Now this thing only applies in a closed system. A closed system means there is no external force acting on the bodies. So in a closed system, conservation of momentum says that sum of initial momentum is equal to sum of final momentum. That's it. Now, how does it apply? Let's assume the scenarios we have been always looking at. Consider a body with mass m1 moving with a velocity u1 and a body with mass m2 moving with a velocity u2. Now, these two bodies are going to collide. After collision, let's assume that the body mass with mass m1 will move in this direction with a velocity v1, and the body with mass m2 will move with this velocity v2 in this direction. Now the sum of initial momentum would be m1 u1 plus m2 and negative u2. As I said, velocity is a vector quantity, momentum is a vector quantity. We have to consider the direction. So u2 is moving toward left, so I said my left would be negative, and my final momentum would be m1 negative v1 plus m2 times v2. And my principle of conservation of momentum says that these two sums, initial, that is before collision, and final, that is after collision, should be same. That means m1 u1 m2 u2 subtracted should be equal to negative of m1 v1 plus m2 v2. As simple as that. Now you can figure out u1 u2 m1 m2 whatever unknown from this equation. The only thing that is important here is considering the direction of the motion. You have to consider the direction of the motion and assign the signs, respective signs, to the velocities, and then only this will be true, or else you will always arrive to a wrong answer. Now the good part till now was that whenever we were dealing with conservation of momentum or momentum, everything was one dimensional. When I say one dimensional, that means either thing body was moving in horizontal or the bodies were moving in vertical. There was no other motion available till AS. But in AL, we will be considering with two-dimensional motion. When I say two-dimensional, that means your body can move in a direction which can be combination of horizontal and vertical. That means here you need to refresh your idea about resolution of vector. Let's quickly talk about resolution of vector. So let's consider that there is a vector, velocity vector v, which is making an angle theta with the horizontal. So we know that if that is the case, then this will become v cos theta, this will become v sin theta. Now I'll not go into trigonometrically how, using trigonometry, how we come across v cos theta, v sin theta. I have already told that many times in the class, but important thing to remember is that since this component is attached to theta, that's why we say it's cos theta, and there is no attachment of theta, that's why we say it's sin theta. The other way around it can be, consider a velocity vector v which is making an angle theta but with the vertical. Now when this scenario comes in, we use the same concept, attached with theta becomes cos, so that means this will become cos theta and this will be sin theta. Now one misconception that I've always heard is that vertical will be cos or horizontal will be sin. No, nothing like that. It all depends on where the angle is measured from. If it is measured from your vertical, then things will be different. From horizontal, things will be different. You can use trigonometry, sin theta, cos theta, opposite, adjacent, hypotenuse, all these things to figure out, but just in case of remembering, remember that whichever component is attached to theta will always be cos theta. Now let's assume a scenario. Now there can be there can be explosion, because I said that the before and after thing. So before what or after what? So before explosion, after explosion, or before collision or after collision. These are the two things that can happen. There can be an explosion, there can be a collision. Now, when we talk about explosion, there is one simple thing that we need to know. Whenever there is an explosion happening, the initial momentum is zero. The sum of the initial momentum is zero. Let's consider a scenario. Let's have two bodies, mass m1 and m2. They are together. That means they are at rest right now, and the velocity is u1 is 0 and u2 is also 0, and then there will be a collision. That means your body with mass m1 will go somewhere in v1, and your body with mass m2 can go somewhere v2. This is what collision explosion is all about. Initially the momentum is 0, there will be final momentum, and you have to then use the principle of conservation of momentum that I'll take you through. In collision, let's talk in detail about collision. So when we talk about collision, let's consider, we'll take a very simple scenario where the body with mass m1 is moving with a velocity u1, and there is another body m2 which is moving. Let's take it very simple. So let's say the velocity here is 0, and after collision what happens is the body with m1 moves in a direction like this, which is making an angle, let's say alpha, with the horizontal, and the body number 2, now this is just a representation, I'm representing thing, it's not a scaled version of it, so things will not be in a real scenario not be like this. So body with mass m2 started moving with velocity v2, which is making an angle beta with the horizontal component. Now, before even going ahead, one thing we understood from here is that initially there is only horizontal component, no vertical component. Later on, that is after the event, there will be a horizontal, vertical, horizontal, vertical. So to make things simple, what you can do is that whenever you come across these type of scenarios, whenever there is a component, figure out the component initially. So what I'll do is that when in the space that I have in my paper, I'll say this is v1. So my component would be v1 cos alpha, and this one would be v1 sin alpha. This v1 cos alpha is the horizontal, v1 sin alpha is vertical. Now you have to remember what is the horizontal, what is the vertical, because that is the main thing here. And here the angle was beta and the vector velocity vector was v2. So we say this is v2 cos beta, and this is v2 sin beta. Now since we have resolved the component, we'll not talk about these v1 and v2. We'll not talk about these v1 and v2. Forget about them. There is only horizontal and vertical now. Now, as we used to do in the projectile, we used to do one thing in projectile is that whenever we used to talk about vertical things, vertical displacement, vertical velocity, we always talk about vertical components. We never think about horizontal. Similarly here also, when we apply the law of conservation of momentum, we will apply it either in horizontal or in vertical. So let's start with vertical. Chalo, let's start with vertical. So now in vertical, initially, so initial scenario before the collision, we can say that there is no vertical velocities here. That means vertical velocities are 0. So that will directly means that your vertical momentum is 0, but still, for the sake of maths, I'll say m1 times 0 plus m2 times 0, and this gives me sum of initial. Now this is vertical, I'll just write down v is 0. Now in final, that means after the collision, let's talk about the vertical. Now here we see the momentum of this mass m1 In vertical direction is m1 v1 sine alpha, and for m2 is v2 sine beta. As I said, momentum is a vector quantity. You have to take the consideration of direction. That means my momentum would be m1, velocity is v1 sine alpha, v1 sine alpha plus, I'm taking the total momentum, total final momentum, m2, velocity is downward, so it would be negative. So I'll say m2 negative of v2 sine beta. And I'll say the sum of final momentum in vertical direction would be m1 v1 sine alpha, m2 v2 sine beta. As you can see, I have used the negative sign. And as I said, we have to apply the conservation of momentum. So we have initial sum, final sum. When we apply the conservation of momentum, it says that initial sum of initial should be equal to sum of final. If you have realized that I'm using only vertical component, and it would be 0 times m1 v1 sine alpha subtracted by m2 v2 sine beta. That means m1 v1 sine alpha is equal to m2 v2 sine beta. Now one thing you can understand from here is that if, now this is a very important thing, okay, you have to remember this thing. If there is no vertical motion, there is only horizontal. Most in your exam you will see such question where there will be no vertical motion, only horizontal motion. That means after the collision, if there is any vertical component, they will balance out, they will be equal and opposite. So even without doing all this thing, all these maths, if you have seen a scenario like this in an exam where you see that there is only horizontal component, there is no vertical initial component, that means your vertical final components will balance out each other. That means m1 v1 sine alpha will be equal to m2 v2 sine beta. You can directly write down, you can think about it, they both will be equal. First thing. Now let's go to horizontal components. Now the thing that we did in vertical, we're going to do the same thing. In horizontal, we see that m1 u1 m2 0. There is m1 times u1 plus m2 times 0. That gives me sum of initial momentum in horizontal component will be equal to m1 times u1. This is my initial. Now if I go to final, when I go to final, I can see that m1 v1 cos alpha 1 in this direction, m2 v2 cos beta 1 in this direction. They both are individual, we should add them. So I'll get m1 v1 cos alpha plus m2 v2 cos beta. This is my sum of initial. And now we are using, this is my sum of final momentum in horizontal direction. Now we're gonna just equate these things, and I'll get m1 u1 is equal to m1 v1 cos alpha plus m2 v2 cos beta. Now the question rises, yes, we understood what to do, how to do. You will see in your question, in your exam, they will ask you what is, they can ask you, they will not give you the value of v2, might be, and they'll ask you what is the momentum of m2 in this direction. Or they can ask you, after giving everything, what is the value of beta. So remember this thing, whenever you figured out, here you can figure out what is v1, what is v2, you can do that. The opposite of resolution, that means if you know vertical, if you know horizontal, and you want to know, let's say this is A, this is B, and you want to know the resultant. We know that your resultant, now you have to use simple Pythagoras theorem. Your resultant would be under root a square plus b square. If you want to find out theta, so we know that tan theta will be opposite. Now the thing is that how can it be opposite? We know that if a vector is there, you can just take the vector and you can move this vector. So let me try to move it. So I can move it here. Now obviously I'm not drawing a scale diagram, so my diagrams will not be that perfect, but if I moved it, this is also B. I have not changed the orientation, I've just placed it somewhere. Now it is making a right angle triangle where this is theta and tan theta is opposite upon adjacent, so this will be B upon A. So theta will be tan inverse of B upon A. So this is how you can use momentum concept in your 2 dimension. I'll just quickly take you through. You have something like this. Now the thing is that I have made it very simple here. There might be a chance that even in the initial part there will be some velocity which will be having horizontal and vector. For an example, let me add it. So it can be something like this, that this velocity u2 which was not 0, it was like this. Now in this case they will tell you there will be something which will give you the angle theta. They will tell you the theta, and then you can figure out this will be u2 cos theta and this will be u2 sin theta. And then when you talk about vertical, there will be a vertical component u2 sin theta. When you talk about horizontal, this part m1 u1 plus m2 u2 cos theta will be your horizontal. And then the similar thing you will have on the after, that is the final scenario after the collision, after the explosion, and you have to resolve it and do it in the same way. Now how to be good at it? Take some random numbers, take some random questions, start practicing, start resolving. You should practice at least 3 to 5 questions where you're resolving, where you're applying conservation of momentum. Then only you will be able to do it perfectly. So that's all about momentum in 2 dimension. Thank you.